Lesson 12.7 part 2, what we're going to do today is we're going to do the second half of the lesson that we did yesterday, which was using sine, cosine, and tangent to find out the angle measurements of a right triangle. Now, who can tell me what the acronym for sine, cosine, and tangent is? SOHCAHTOA. Perfect. SOHCAHTOA. And what that stands for is sine is the opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? If I had a right triangle, let's say for instance, and I wanted to know the measurement of angle B, I would have to know that this is the side lengths here. Okay? And then I would just ask myself, if I want to find the sine, I know I can find the opposite over hypotenuse. So the opposite of angle B is 4 over hypotenuse, which is 5. Now, if I can reduce that fraction, I will. But if I can't, the sine of angle B is just 4 over 5. We could do the same thing for cosine and tangent by plugging in the correct numbers, okay? So what we're going to be doing today is we're going to be solving the right triangle, but this time we're going to be looking for the side measurements and not the angles, okay? So what I'm going to have to use is I'm still going to have to use SOHCAHTOA in order to plug it in and solve. But what I need to remember is that it's going to be a little bit different. I'm solving for a side I don't know. I don't know what the measurement of R is. I don't know what the measurement of P is. So what you're going to start by looking at is the angle measurement that they have given you. Look for the angle measurement. What is the angle measurement that they've given you besides the 90-degree angle? 30 degrees. So I'm going to do everything based on my point of view from that angle. We're going to find the sine, cosine, and tangent of the 30-degree angle. That means that's going to help me find the different side lengths, okay? So what I want to do before I do anything is I want to go ahead and label the sides. So I know which side is opposite, which side is adjacent, which side is hypotenuse. Let's start with the hypotenuse because that's usually always the easiest to pick out. Which side is the hypotenuse, Jensen? R. Okay, so let's label it hypotenuse. Now, which side is opposite? Remember, we're looking from the 30-degree angle. So which side would be the opposite? 5. Because if I were to take a line and draw it straight from my 30-degree, I'd run right into my opposite side. So I'm going to label this opposite. And last but not least, that tells me that P is the adjacent side. Okay, so I want to find R and P, which are my hypotenuse and adjacent. So I'm going to write down SOHCAHTOA because it's going to help me in figuring out what to do. So I'm going to write SOHCAHTOA. And then I'm going to ask myself this question. What side do I know? Do I know the opposite? Do I know the hypotenuse? Or do I know the adjacent? The opposite. I'm going to circle each ratio that uses the opposite. So that's SO and TOA, or sine and tangent. So I know those are the two ratios that I'm going to use to solve for R and P. Okay? It makes it much easier if you start out doing that. Okay, so let's solve for the sine. First of all, when you're doing it based on an angle measurement, this is where your calculator comes in handy. Because I'm going to find the sine of the angle that they've given me. Well, I'm not going to plug in sine of M like we did yesterday because I don't know the numbers that are the side lengths. So what I've got to do is I've got to do the sine of 30 because that's the degree of angle that they've given me. So we do the sine of 30 is equal to opposite over hypotenuse. Well, I know my opposite is 5 and my hypotenuse is R. I don't know what R is and I want to solve for it. So now we have the perfect blend of algebra and geometry because I've got to use algebra to solve for the side length of R. This is where your calculator is going to come in handy. In order to find the sine of 30, you're going to click the sine button on your calculator and then type in 30 and press enter. What you should get is a fraction. I want you to change that fraction to a decimal. Somebody tell me, what decimal do you get? Jensen?
0.4539905.
Megan, what did you get?
0.5.
0.5. 1/2. Okay? So the sine of 30 is just 0.5. So now I'm going to plug it in and I'm going to write 5 over r. So this is where we just solve for r. But let me teach you a little shortcut here. And this is what you got to pay attention to. Anytime your variable is on the bottom of the fraction, the variable has to be on the bottom of the fraction to do this. If it's not on the bottom, you cannot do it. Okay? So if I want to make it easier on myself to solve this, I can just switch the variable and the sign. And I'm going to write r is equal to 5 divided by 0.5. Plug that in my calculator and solve for r. When I plug that in, what do I get? 10. There's one of my side links right there. Now you say, okay, why is that a shortcut? Why could we just switch those? Because we've never been allowed to do that before. This is why. Because I've got to get r by itself. I need to solve for r. So typically you would think, okay, well 5 divided by r, I just need to divide by 5 on both sides and get my answer. But that's not technically true. Because when I divide by 5, what would I still be left with over top of the r? 5 divided by 5 is 1. So that still leaves me a fraction. So technically, what I have to do is I've got to say, okay, I need to multiply by r, which cancels that out, and multiply by r. And then I have 0.5r is equal to 5. Then I would have to divide by 0.5. And I would get r is equal to 5 divided by 0.5. And I could simplify that. But instead of me making you show all that work and do all that, it's easier for you to know that a shortcut means only when the variable is on the bottom can I just flip the sine or cosine or whatever you're solving for and the variable. Okay, does that make sense? All right, so now we found side r, but I still need to find what? Side p. So I've already used sine here. What's the only other thing that I'm going to use? Tangent. So let's find the tangent of 30. Don't forget, we're always going to use 30 because that's the angle measurement they've given us. And I'm going to do the opposite over adjacent. Well, my opposite is 5. And do I know what my adjacent is? Nope, so I leave it as p. All right, so let's plug in our calculators. What is the tangent of 30? Betty?
When it rounded to the tens or
3 decimal places.
0.588.
It would actually be 0.577. Because what you do when you do 3 decimal places is you look at the decimal behind, or the number behind the last 7, and it either rounds it up or keeps it the same. And then I get equals 5 over p. Now, do I have a variable on the bottom of the fraction? Yes. So can I switch it? Yes, you can. So I'm going to write p is equal to 5 divided by 0.577. And what is p equal to when you do that?
8.666.
So we're going to do 8.67. Now, when you've got your answers, you can just round to 2 decimal places. But we want sine, cosine, and tangent to be as close to the correct number as possible. So that's why we do 3 decimal places. Okay? So these are my 2 side links. And that's how I use sine, cosine, and tangent to find the side links. Okay, let's do another one like this. Find the length of side A and find the length of side B. First of all, let's locate the angle measurement that we are going to use. What is the angle measurement we're going to use? 55. So I'm going to look at everything from that viewpoint. But let's go ahead and label our hypotenuse, because that's always the easiest one to do. Janae, what is our hypotenuse? 12. Now, in relation to angle 55, Hunter, what is the opposite side? B, perfect. And Dean, what is my adjacent side? A. So of those three sides, hypotenuse, adjacent, and opposite, I'm going to ask myself, which one did they actually give me a number for? Which one did they give me a number for? The hypotenuse. So I'm going to write SOHCAHTOA. And I'm going to circle the two that use the hypotenuse. Which ones are those? So and ca, which is sine and cosine. All right, so let's first do the sine. We're going to do the sine of angle what? What do I have to plug in my calculator? 55 is equal to opposite, my opposite is B, over hypotenuse, which is 12. Somebody tell me, what did you get for the sine of 55? Round off 3 decimal places. 0.819 is equal to B over 12. Now let me ask you this. Can I just switch B and 0.819? No, because the variable has to be in the denominator in order to do that. Now we're just going to use regular old algebra and ask myself, if I wanted to get B alone, what would I do? Multiply by 12. Cancels that out. Whatever I do to one side, I've got to do to the other. And I'm going to plug in my calculator 12 times 0.819. 9 point what? 83 is side B. Okay, now we used sine. So we're going to now use cosine. We're going to do the cosine of what? 55. And the cosine is adjacent over hypotenuse. So my adjacent is A, my hypotenuse is 12. Can I just flip-flop the cosine in the A? No, because A is not on the bottom. What did you get when you put the cosine of 55 in your calculator? 0.574 is equal to A over 12. So how would I solve for A? Multiply by 12. 12 times 0.574 is what? 6.89. And this is the length of side A. Okay? And last but not least, let's do one more of these. First of all, the angle measurement that I have is 53 degrees. And I'm going to do everything based off of that angle. So let's label our sides looking from the viewpoint of the angle that has a measurement of 53 degrees. Which one of these sides is our hypotenuse? C. Which side is the opposite? 17. And which side is adjacent? B. So of these three sides that I just labeled, hypotenuse, opposite, and adjacent, Hunter, which one did they actually give me a measurement for? The opposite. So I'm going to write SOHCAHTOA. And I'm going to circle the sine, cosine, or tangent that uses the opposite. So I'm going to circle sine and tangent. So I'm going to do sine of what measurement?
53.
Sine of 53 is equal to opposite, which is 17, over hypotenuse, which is C. So let's plug in. What's the sine of 53? 0.7799 equals 17 over C. Now, can I replace 0.799 in C?
Yes.
Yes, because the C is on the bottom. So we write C is equal to 17 over 0.799. And what is C equal to?
21.28.
Very good. 21.28. Now let's find the measurement for side B. And I've already used sine, so I know I'm going to use tangent. So we're going to do the tangent of what? 53 is equal to opposite, which is 17, over adjacent, which is B. Tangent of 53 is what? 1.327 equals 17 over B. Now, can I swap 1.327 with B?
Yes.
Yes, because it's on the bottom. So I write B is equal to 17 over 1.327. Go ahead and divide, and what do I get? 12.81 should be your measurement for side B. Okay? So this is how you would find the measurements of the sides using sine, cosine, and tangent. Okay? This is your classwork that we are going to do. You've already done number 13, so go ahead and work on 14 through 18, and then we will check it in a few minutes.